And good morning, everybody. Happy Monday. Missed you this weekend. Mr. Daniel had a good time, though. His daughter graduated college. How cool is that? Yeah, got a fun trip up to Humboldt State. Watch her graduation. Anyway, hope everybody else had a good weekend as well. Let's do this warm up, okay? We got a 4x4, Ken. Just a reminder, that little backslash, that means divide, right? So if you had 12 backslash 3, that's 12 divided by 3. What's that? Hopefully you said 4, right? So that means divide. All right, so copy that down. I will zoom in a tiny bit. I think everything is clear enough that you can copy everything down at once with one pause, okay? All right. All right, let's see how you did. First off, we got 4 diamonds, most popular diamond ever. If you don't know that, then you are not trying hard enough. You need to write that down and memorize that because we've had that for a long time. How about 54 and 15? Two numbers that multiply together give you a product of 54, and you add together give you a sum of 15. I know some people say 7 plus 8 is 15. 7 times 8 is not 54, though. 10 plus 5 is 15. Yeah, but what's 10 times 5? Only 50, huh? This is where you go 9 times 6. Okay. 48 and 14, 14. I like saying 14, all right? It's one of my favorite numbers in Spanish. It just sort of sounds cool. All right. Kind of like saying adwala. Adwala. Kind of makes your tongue happy, huh? All right. Where are we? Back to business. 8 and 6. How about 56 and 15? 7 and 8. Okay. Now, we'll go to this in a little bit. Let's go ahead and do the rest of this. And 9 64ths, the square root. Well, 3 times 3 is 9, and 8 times 8 is 64, right? Don't put an 8 here, right? 4 times itself is 16, and 9 times itself is 81. So the square root of 16 over 81 is 4/9. Okay? And just out of curiosity, what do you think the square root of 4/9 is? I just recognize that those are both perfect squares. That's rare. You can get that too, huh? All right, 25 over a gross number. Ooh, that's gross. A dozen. Remember, that's called a gross. 12 is a dozen, 144, a dozen. It's called a gross. That's the name for it. What is the square root of 25 over a gross? 5 over a dozen. And 49 over 256, hopefully you said 7 over 16. When you multiply decimals, your first step is to pretend there's no decimal. A lot of you guys like to pretend that I don't see you doing what you're not supposed to do. Yeah, some of you never do what you're not supposed to do. Little angels. Some of you, a little sneaky. I see you sometimes. 3 times 1. 3 times 4 is 12. Carry that 1. 3 times 2 is 6 plus 1, 7. Let's put a placeholder because that 1 is really 10, right? I go cross out all my tally marks if I carried, so I don't get confused with the second round. But this is just a 1 anything, right? 1 times anything is itself. So I'm going to go 241 on that because 1 times 241 is 241. Now I get 3133. But that was not really 13. I had to move the decimal over 1 spot to make it 13. That was not 241. It was 2 and 4100ths. I had to move the decimal over 2 spots. 2 there, 1 there. That's a total of 3 spots that I have to go back in my answer. 1, 2, 3. So 3 and 133 thousandths. And that kind of makes sense that I put the decimal there because if I rounded this and estimated, I'd say 1 times 2 is 2, right? I know it'd be bigger because that's 1 and 3/10 and 2 and 4/10, right? So 3, it only makes sense to put it there. Okay? All right. First I do is rewrite it. The first number goes inside the box. That's a 27 and 2/10. The second number goes outside the box, which triggers an alarm, and the police start coming to get me just in case. They're going to watch me like a hawk to make sure I don't do what? They're going to make sure I do not divide with the decimal outside the box. I have to get rid of that decimal outside the box. How do you get rid of it? Well, where do you not need it? You don't need it if it's on the right. So if I move this over 2 spots, I no longer need it, then I can get rid of it. But remember, if I move it over 2 scoops outside the box, I need to move it over 2 scoops inside the box. And in this case, I got to fill that egg carton. Now look at that problem and raise your hand if you're smart. If your hand's up, you're smart. What do you do right here before I start dividing? Because I got these 8 I got 4 scoops and 4 decimals. That's confusing. Yeah, hopefully you said rewrite that problem. Okay, rewrite the problem, and it only takes about 5 seconds usually. Okay, but this looks so much easier than that. Okay, now I'm saying 16 goes into 27 one time. 1 times 16 is 16. Now I subtract. What do I do now? Bring down that next number. And 16 goes into 112 7 times, and that's a perfect fit. What do I do now? Bring down the next number, and 16 goes into 0 times. So 170 ends up being my answer there. Okay. Okay. Now, when I add fractions, I need to make sure the number on the bottom is the same. I can't add 3 pesos and $2, right? I need to convert them to the same denomination of money, right? Now, I can convert them both to dollars, both to pesos, or both to Japanese yen or euros, right? It doesn't matter. It has to be the same denomination. Same thing with fractions. It has to be the same denominator when you add or subtract. So eighths and fifths, 5 is prime. So I am going to just multiply 5 times 8 and change this to 40. So I said 5 times 8. So now I got to go 2 times 8 on top. I did 8 times 5, so I got to go 3 times 5 on top. 15 40ths plus 16 more 40ths equals 31 40ths. Raise your hand if you got that right. Pat yourself on the back. Good job. Now, multiplying fractions is what? Easy. Why? Because all you got to do is multiply across the top, multiply across the bottom, and sometimes just simplify. Since both of these are even, I know 2 goes into both of those. 2 goes into 6 3 times. 2 goes into 40 20 times. Now, I don't know if you recognize, I could have taken a little bit of a shortcut and cross-canceled, which basically means you're going to simplify before I start, right? Because 2 goes into the top once and goes into 8 4 times. So I would have had 3 times 1 on top and 4 times 5 on the bottom. Look familiar? Yeah. So I had smaller numbers to multiply, and I didn't have to simplify when I was done. Okay. Now, same idea for this problem as this problem. I need common denominators. 2 fifths and 3 eighths. Now, we already found out what those are in 40ths, so we already did the work ahead of time. 3 eighths is 15 40ths. Why? Because 8 times 5 is 40, 3 times 5 is 15. Multiplied by the same number on the top and bottom. Remember what that looks like. That's where that magic 1 comes in. Right? You can multiply anything times 1 and it won't change its value. Right? So if I have 5 over 5, that's 1, right? 5 fifths. That's why that works, right? Okay, now we aren't really using that magic 1 explicitly like that. We're kind of doing it in our head, that part, right? I go 5 times 8, so I go to 2 times 8. And then 16 40ths minus 15 40ths leaves me with a 1 measly little 40th. All right? Okay, on to the kin. All right, where do you want to start? Well, this is definitely a tougher one to get started on. Okay, so hopefully I will pause this after I get you started. Okay, and where I'm going to start is all these 2 divided bys. Okay, how can I get the answer of 2 when I divide 2 numbers and the numbers have to be between 1 and 4? Well, the only way I can do that is go 4 divided by 2 is 2, or 2 divided by 1 is 2. Now, those numbers 1 through 4, there's a number missing out of the possible numbers there, right? You guys know what it is? What is it? Hopefully you said 3, which means I cannot have a 3 in either of these boxes, either of these boxes, and either of these boxes. So I can't have a 3 in either of these boxes. So where does a 3 go in that last row? Yes. Okay, now if a 3 goes there, what's going here? Yes. Now, if I have a 4 divided by 2 here, that would be a 1, but I can't have a 4 here, can I? I could have a 4 here, though, couldn't I? think so. Can't have a 4 here. So here's the deal. I need to have a 4 somewhere down here, right? But wait a minute. I need to have a 4 and a 3 here, or a 3 and a 4 can't go there, right? So the 4 is going to go there, and a 3 is going to go there, right? So that leaves me with a 2 and a 1, or a 1 and a 2. I don't know which yet. A 2 and a 1 and a 1 or a 2. I don't know which yet, right? Now, another thing I recognize is I can't have a 3 in either of these two boxes, right? Remember, we looked up here. I can't have a 3 in either of these two boxes. So I can't have a 3 in either of these three. So where's the 3 going to go in that third column? It has to go up there, right? Now I have a 3 in this column, this column, this column, but not in this column. This row, this row, this row, not this row. So the 3 goes where? And here I have 3 minus something is 2. That's going to have to be a 1. I need a 1 in this row or this column. Can't go here. What's left in that first column? What's left in that top row? What's left in the second row? What's left in the second column? Okay, and now on this one, I need this to be either 4 divided by 2 is 2 or 2 divided by 1 is 2. Can I put a 4 there? So what has to go there? What's missing in this column? 4, right? Is 4 divided by 2, 2? Yes. What's missing in the bottom row? What's missing in the third row? Is 2 divided by 1, 2? Yeah, looks like it works. All right, you guys, have a great Monday. Have a great week.